Here I am once again, and in today's video, we will be demonstrating the impact of prompt engineering on an LLM, that's large language model if you've been following the video, on an LLM's performance. And we're going to select a task and iteratively apply 3 distinct prompt techniques in order to improve the model's output quality. And we're going to be using a pre-trained LLM via the Hugging Face API in order to get this done, and we've got a Jupyter notebook for you to follow along with again. To begin, we'll start with a baseline test where we define the tasks and create a simple unoptimized baseline prompt, and then we'll run the model and record the low quality result. So let me tab over to this. We've already done it because it does take a while to run on the local machine. As I was just saying, here's the unstructured review. For this assignment, I decided to go with a model's ability to parse information that can be used effectively in a JSON structure to pull that from a customer review. I thought that was a challenging but fun task. So the unstructured review, as you can see, order was placed, super comfort ergonomic. I know it's ergonomic, it's from the Office keyboard, arrived quickly, but the left shift key immediately stopped working after 2 days. Price was $120, which is quite expensive for such poor quality control. I will be returning this item. Overall, the experience was frustrating. Sounds like a negative review. Um, yeah, definitely is. So there's the JSON structure, the name, price, date purchased, customer sentiment. We got positive, negative, neutral. We don't have stars. So here's the prompt definition. Extract the following information. The required format is strictly JSON. There's the format, and then there's the text. And we have to get some transformers here in a pipeline. And here is that. We went with the Mistral 7B model. That's been doing me quite well, 7B for 7 billion. And there's the unstructured review, required JSON format, the baseline prompt. Kind of just went over all that. When we tell it to execute and get the result, we have it adjusted for 256 tokens. And there's the baseline output and give us the result. I don't know what's that. I'm not going to get into that. And let's see here. As we were, here's the output and the required format again. This is just part of the based on the print statements. So here's the input. It knows what to do. Here's the output. It's given us the, doesn't look like JSON format. I don't see the 3 commas, but it does tell us the name, the price, the date purchased, and the review, which is very good considering that this is like supposed to be like the subpar model. So next we'll do some role prompting. We're essentially saying it's the senior data scientist, and its goal is to parse the JSON. Nothing really that different. Just trying to make it very serious about it. And more of the print statements about how we want it to look. But yeah, the results suggest that even the chosen model, the place, like, it's already pretty good, is what I'm trying to say. It's actually surprisingly good. Since it was so good, we can conclude that it's really not a limiting factor. So now the challenge is coming up with another challenge, which is focusing on areas where functional models often fail, which is strict adherence to that formatting. As I said, that JSON structure is looking a little bit iffy. So in the next technique, it involves using that adherence based on a concrete example. following clear delimiters and demanding the output be wrapped in a specific markdown tag like JSON to prevent leakage. So extract the four data fields. The final output must be valid JSON. Wrap it in a JSON markdown block. Do not include anything outside of the JSON block. Go. So we all know what the prompt, we all know, just to go over it, the instructions are, we know what the required schema is. Here's the input text. And now here we go for technique 2. So there's the negative review. And now we have the JSON structure. And much the same other than that, it looks like. So while it was good, this does confirm that adding strict delimiters and markdown for each is a highly reliable way to force the LLM into the desired output mode. And this can help prevent leakage, as I mentioned. So since it's already really good on that, I'm going to use chain of thought prompting to address the reasoning process. Why? Why is the review negative? It doesn't necessarily improve accuracy, but it's crucial for debugging complex prompts and confirming the model's logic, it's really cool. But in a production environment, you're not going to be doing that just because it's going to take up more resources, like if you were just having it on your application usually. So here's the prompt 3. Senior data scientist, analyze and tell a brief paragraph about the customer service sentiment and why. And 2 hours later, here's what it gave me. Again, just kind of the print outputs. More of that. Here's the input. And now, what does it have? The reasoning. The customer's experience with the super comfort ergonomic keyboard was not positive. They reported that the left shift key started working. Just after 2 days, they found it to be too expensive and poor quality. They had a negative experience, which led to their decision. Therefore, the sentiment is negative. Yeah, that's correct. Got it correct. And the structure, boom. So that looks good. It successfully executed both phases of the instruction, demonstrating a significant improvement in process adherence and transparency. Even though the final output was already correct, we still learned why it got it right, but it's usually done for why I think it got it wrong, COT. But I think it's cool. The model correctly separated its output into the request as well, and it showed it can be guided through multi-step sequential processes. So all 3 techniques, role prompting, strict formatting, and chain of thought, have proven effective at ensuring accuracy, format adherence, or process transparency are working or in place or are being monitored. And if they're not in place, we'll know. So now we're going to combine the most successful and non-redundant elements into one powerful final optimized prompt. And it might be worth noting that, as I said, in a standard environment, chain of thought would be omitted from this to save on token cost unless the task required it. So to combine the COT logic, strict delimiters, and markdown guardrails, you're a senior scientist. Your goal is to provide perfectly formatted code before generating a justification. It must be strictly JSON. Do not include anything. So just really dialing down. Let's see how it does. And this one did take a while. I'm scrolling quick because you don't need that. You've seen that. Reasoning. They received additionally. So yeah, same thing, same thing. And it just suggests that all 3 have been integrated in order to produce a really, really well justified output. And it demonstrates that the highest level of instruction of adherence for this task. So it got it done right, and while maintaining a high accuracy on the baseline. Initially, this transforms the results from simple text generation into a reliable, structured, and audible data transformation tool, which is really the advanced goal here. Thanks for watching.